Section 11.7, we're going to start looking at how area and volume of similar solids will relate to each other. So the first thing we have to do is we have to define similar solids. Similar solids will have the same shape and all of their corresponding dimensions are going to be proportional. So let's look at some examples. We need to figure out if we are going to have similar shape and proportional dimensions. So the directions are specifically towards these two rectangles, but we're going to use the same idea for the cylinders and then the U-try as well. So the first thing I have to do is I have to match up my dimensions, because if I'm looking at these shapes, I see that they are the same. I have two rectangles here, I have two cylinders here. I don't have a rectangle in a cylinder or a pyramid in a cylinder. So now I'm going to check and see whether I have proportional dimensions. So this 3 goes with this 6, this 3 goes with this 6, and this 2 goes with this 4. You can see that just looking at your picture. So I want to know, is 3 over 6 equal to 3 over 6 equal to 2 over 4? And that's my small over my large, just so I remember. Well, 3 over 6 is 1/2, 3 over 6 is 1/2, and then 2 over 4 is also 1/2. So, yes, they are similar. And my scale factor is the simplified or reduced fraction, so 1/2. And it does say in the directions of the first figure to the second figure, which is my small to my large, which is how I set it up. So now I can go ahead and I can take a look at the second example. I'm going to do that example in red so you can tell the difference. And I see that I have two cylinders, so I have similar shape, same shape, but I need to see if I have proportional dimensions. So I see that my 6 is my radius. That's going to go with my 5, which is my radius in the smaller figure. So now we have large over small. And then my height of that cylinder is 12 over 10. Are these proportional? Well, yeah, because if I take 12 over 10 and I reduce it, I divide both of those things by 2, I get 6 over 5. So yes, I do have proportional dimensions. My scale factor of my first figure to my second figure is 6:5, or 6:5. Remember, that's the other way you can write a ratio. Okay, so there's a U-try problem for you to do. And then we're going to take a look at a slide that we actually saw in the 10-4 notes. So I have this, or you should have this in your notes somewhere. I've got it in past slides. We need to recall the relationship between perimeter, area, and volume. If you remember, your ratio of your perimeters of two similar shapes are going to be the same as your similarity ratio, or your scale factor. But the ratio of your areas is going to be your scale factor squared. And then, last but not least, the ratio of your volumes is going to be your scale factor, or your perimeter ratio, cubed. So we need to make sure we know those things for the next few problems. All right, so let's take a look at this first example. I'm trying to find my scale factors of my smaller prism to my larger prism. But I see that they haven't given me dimensions. They've given me the volume of each of these two prisms. So what I need to remember is what we looked at a few slides ago. And I know that my volume, the ratio of my volume, is going to be cubed from my scale factor. So what I'm going to do is I'm going to write 729 over 1,331. But because I want to get all the way back to just being my scale factor, I need to take the cubed root of that. So what I can do in my calculator is I can break that down into two different cubed root problems here. And remember, I showed you in your calculator, it has a button. It's the x root, or the x radical. So you can put in 3, and then you hit your second button to get the x radical. And you ask what the cube root of 729 is and what the cube root of 131 is. And the answer that you'll get is 9 is the cubed root of 729, and 11 is the cubed root of 1,331. So this is my scale factor of the smaller prism to the larger prism. All right, so let's take a look at this second example. Now I've got cylinders, and they told me my surface area. Again, thinking back to that slide, my surface area is the square of my scale factor. So if I take my smaller to my larger, I get 20 pi over 125 pi, and the pi's cancel out immediately, so I don't have to worry about those. I just have to think about the square root of 20 and the square root of 125. Square root of 20, if I simplify it, my calculator can help me with that, or you can do Joe's method or a factor tree. You get 2 radical 5, and the square root of 125, you get 5 radical 5. And what happens then is that these radical 5s cancel, and you know that your scale factor of your smaller cylinder to your larger cylinder is 2 over 5, or 2 to 5. So you go ahead, there's an example there with cones for you to do. So these problems get a little bit harder because now we have to take that basic idea that we just learned about, but we need to apply it in like a second step to determine an actual value for volume or surface area. So in this first example, I've got the lateral areas are given to me of 2 similar paint cans. They tell me that they're 1,019 centimeters squared and 425 centimeters squared. They also give me the volume of the smaller can, and they want me to find the volume of the larger can. So what I have to do here is I have to take my areas, and I need to find my similarity ratio, or my scale factor. So I'm going to square root, just like we did in those last problems, to get backwards to my scale factor. Then, though, I need to take that, and I need to use it to get my volume. So I'm going to cube everything. So let's take a look. Let's start setting up and see what unfolds here. Let's do smaller can, larger can over smaller can, because that's what they gave me in the first one. Here's my large, here's my small. So my surface areas are 1,019 over 425. So I need to take the square root of those two numbers. When I take the square root of 1,019, that actually gets me a decimal, 31.9. I don't want to use a decimal, so what I'm going to do is I'm just going to leave my answer as square root of 1,019 over the square root of 425. That's going to be my scale factor. So instead of reducing that down, I'm just going to leave it that way. So let's identify that as our scale factor. Now, though, what I need to do is I need to take that and I need to cube the whole thing so I have the ratio of my volumes. So let's take that whole thing, 1,019 over square root of 425, and we are going to cube it. All right, so when I do this, I end up with 1,019 under the square root cubed is going to give me 8,761.599454. And I'm not going to round because I'm still working within my problem. Over, if I take square root of 425 and cube it, I get, oops, I'm sorry, I just did that backwards. Let me erase that top number. That's my bottom number. That's when I do 425. So really, 1,019, that'll get me 32,528.29321 over 8,761.59944. Now this might be a little bit more difficult to do if you're using like the calculator on your iPhone, but in our calculators that we use in class, it's actually pretty simple. So I get those two numbers, I'm going to divide them. I'm going to do 32,528 divided by 8,761, and what I get is 3.712597612. Now if I just put that over 1, that's my scale factor. Okay, so I have a scale factor for my volume. of 3.712597612 over 1. That's my scale factor. Now, what I have to do, though, is I have given to me the volume of the smaller can. So I need to take that number, that scale factor, 3.712597612 over 1, and I need to set that equal to my large volume, which is what I'm trying to find, over my small volume. And what I can do here in order to solve this is cross multiply, because now I have a proportion set up. So I get x equals, I need to take this number that we just found as our ratio, and I have to multiply it by 1,157. And my answer that I get when I do that is 4,295. The directions say round all to the nearest whole number. It's 0.4, so that's exactly what I need to do, is round down to 95 centimeters cubed. So this right here is my answer. So we had to go through, we had to start with what they gave us for our areas, take the square roots to get back to our scale factor. Then we had to cube those to get into our volume. That resulted in these two numbers, which we divided and found out that it's this decimal over 1. That now was my ratio of my volumes. So I set the ratio of my volumes equal to my larger volume, which I was looking for, over my smaller volume, cross multiplied, and solved to get my answer. You go ahead and do this next problem. Now we're going to look at a very similar problem. I'm given this picture of this building here. They tell me that it's 480 inches tall, but then in the word problem itself, they say that a bottle is 10 inches tall and holds 34 ounces of milk. This sandwich shop, which they gave us the picture of, is the same shape as a milk bottle. It's just 480 inches tall versus 10 inches tall. So they want to know, to the nearest 1,000 ounces, how much milk could the building hold? Okay, so I have to think first about my scale factor. I know that my smaller bottle, sorry, that's a bad color. My smaller bottle is 10 inches tall, and my really large bottle is 480 inches tall. So my scale factor, if I reduce that, is 1 to 48. That's my scale factor. Now remember though, if we're talking about how much milk this building can hold, we want to know volume. And if we want to know volume, what we have to do is take this scale factor and cube it. So that will get us a volume ratio of 1 over 48 cubed, which is 110,592. Okay, so this is my ratio of my volumes. Now I need to use that. It's my smaller over my larger. They gave me the amount of ounces of milk the smaller bottle will hold. It's 34 ounces. They want to know how much milk can that large building hold. So I'm going to go ahead and cross multiply these two things, which gets me x, which is what I'm looking for, is equal to 110,592 times 34, which is 3,760,128. Now it does say round to the nearest 1,000 ounces, so they just want me to get closest to 1,000. So the actual answer that we are going to give them is 3,760,000. We're going to round that 128 off. Ounces is your answer. And then you've got this last one. My picture's a little bit better though. We've got the good old twisty treat here, which is the shape of an ice cream cone. Now, it's not exactly the shape of an ice cream cone, so I do need you to go ahead and assume that they are actually the same shape, and then you can go ahead and do this problem. I will see you in class.